Hello and welcome back, my dear viewers and my dear students, to part 2 of the session of geometric mean. This is the same module for right triangles in trigonometry, and this video is going to be really helpful for grade 9 students for understanding and applying the geometric mean theorems. So there are actually two parts to this theorem. We will do them one by one, and let's get started. Okay, so let me now explain to you what is the shorter leg and what is the longer leg for the right triangle. So as in the previous theorem, we saw that ACB is the right angle triangle, right angled at angle C. H is the altitude, height. So CD is equal to H, this is the notation. AB is your hypotenuse, which is opposite to the right angle, angle C. Its length is small c and it has two segments, if you can see, x and y. So C is equal to x plus y, the two segments or the two parts of the hypotenuse. Then you have the other two sides of this right triangle denoted by small a and small b. So just remember capital A, capital B and capital C. This is the notation for the angles of the triangle. And small a, small b and small c is the notation for the side lengths. Okay, so small a, small b and small c are the side lengths. Capital C, small a is the longer leg, small b is the shorter leg. So the b is smaller or shorter leg of the right triangle ABC, and A is the longer leg. Okay, and remember the angle opposite to the longer length is more. So angle A is going to be more than angle B. Okay, and that is why B is shorter, A is longer. Now we already know from the previous theorem these three triangles are similar to each other. Now we'll go on a step further and see the relationships between the length of the legs x and y and the length of the hypotenuse and also the length of the altitude h. Okay, so the circle relationships, this one, this one and this one, leads us to the geometric mean theorem. Now there are two parts to the theorem: geometric mean altitude theorem, which will give you the length of h. As you can see here, h square is xy, so h is the geometric mean of the two segments of the hypotenuse. And as you can see from these two relationships, that we will be able to find the length of the legs by taking the geometric mean again. So this leads to the theorems, which are very important. Let's see them in detail in the next slide. Okay, so there are two theorems that are going to connect the geometric mean. Number one, very important theorems, and number two, this one. So I'm sure for your exams you are going to be getting questions from these two theorems, and you will be asked to find the unknown measures, as you would see in the next slide. Okay, so geometric mean altitude theorem. First, let's understand this, and because the name is altitude theorem, it will help you to find the length of altitude. Okay, so this theorem where you need to find the altitude or the length of altitude. If it is asked, that means h is asked in the question, this h which is CD here, the altitude. If this is asked in the question, it's not given to you and you have to find h, then you will use the geometric mean altitude theorem. And if you need to find the geometric mean, if you have to find the legs, if you have to find the length of A and B, these two sides, then you are going to use geometric mean leg theorem. So let's understand the altitude theorem first, and because these are geometric mean theorems, we are going to use the formula for geometric mean, which is square root of the product. Okay, so the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse in two segments. You all can see this is the right triangle ABC, CD is the altitude. It is from the right angle to the hypotenuse AB, and it is divided into two parts, x and y. So these are the two segments, or let me write here, two segments of hypotenuse AB. One is x, one is y. Okay, both are different in length. Okay, the length of the altitude is the geometric mean between the length of these two segments. That means the formula is the length of the hypotenuse, or the length of the altitude here, is square root of x multiplied with y. So this is the formula that you will use when you have to find h, or the length of the altitude. Let's come to geometric mean leg theorem part 2. So what you need to remember here is the formula to find the two legs, so A and B. If you need to find these legs of the right triangle ABC, you are going to be using the geometric mean leg theorem. Again, you will use the concept of geometric mean to solve. So let's see. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. We've already discussed that. So if your hypotenuse is length C, I'm just writing here AB is equal to C, and as you can see, C is equal to X plus Y. The length of the leg of this triangle is the geometric mean between the length of the hypotenuse, so length of hypotenuse is C, and the segment of the hypotenuse adjacent to that leg. So adjacent means near to that leg. So for example, you need to find the length of B first. So AC equal to small b is the smaller leg of the right triangle ABC, and BC equal to A is the longer leg. This is what the length A and B that we need to find, because it is geometric mean leg theorem. So what is the theorem saying? It says if you want to find this B, the shorter line segment, then you take the length of the hypotenuse, geometric mean of hypotenuse, multiplied with the segment near to that, adjacent to that. So the segment which is near is X. Similarly, your other leg is the square root of multiplied with y. Okay, now let's see an example where we apply the geometric mean theorems. So here you will apply the theorem to find your x, to find your y, and to find your z. So these are the unknown measures which are given to you. Now nowhere in the question it is written that use geometric mean theorem, but you have to identify from the figure or from the statement of the question. So look at the figure. KLJ. You can see angle L is 90 degree. It's a right angle triangle. And you can also see that LM is the altitude here, drawn from the right angle to the hypotenuse JK. Now the two parts or the two lengths of the hypotenuse, the two segments are also given. JM is 5. Km is 20. So we can say the length of the hypotenuse JK is 5 plus 20. So 25 units. This is the hypotenuse. Now the two legs, the shorter leg Y, the longer leg Z is not given. You need to find them. So I'm just marking. And all of this, if you notice, I'm writing only from observing the figure carefully. So when you get a question in your exam, first you need to look at the figure of a geometry question like this and notice what all is given, what you need to find, and then proceed how will you find that. So LM is also not given, which is nothing but the length of the height, sorry. That is your altitude here. So we are going to first apply the geometric mean altitude theorem to get the length of this altitude or the value of x. So if you go to the first part of the theorem, it says the length of the altitude x is the geometric mean of the two segments or two parts of hypotenuse. So one is 5, one is 20. Just multiply them, take square root. So this comes out to be very easy, 10. It's a perfect square. So you have your x now. So LM equal to x is 10 units. Now you know the value of x, it will be easy to find y and z. So for finding the shorter and longer leg, let me change color. You are now going to use second part of the theorem, which is the geometric mean leg theorem. So what does it say? If you are finding the shorter leg, you take the length of the hypotenuse. So total was 25. This is the length of hypotenuse and the segment closer to it. So closer is 5. So 5 multiplied with 25. So that's 125. Now, if you don't have your calculator to simplify, then how will you do? Like prime factorization. So this is 5 multiplied with 5 multiplied with 5 3 times. Now because it is square root, this will come out. So this is 5 square root of 5. Okay, so this can be the simplification. You can leave your answer in this form also if you are not having a calculator. Next is Z. So for this Z, again you apply the geometric mean leg theorem, and this time you are going to take the total length of the hypotenuse 25 with the segment closer to it. So the one closer to this Z is 20, so 20 will be multiplied with 25. That's 500. And now you can do the similar procedure. So square root of 500 can be written as 5 multiplied with 525 multiplied with 5 multiplied with 2 multiplied with 2, right? So I've done the prime factorization. You can take the things which are common. So 2 and 5, 10 will come out, and inside you have square root of 5. So you could leave your answer in this form also if you don't have a calculator to simplify. Okay, so the question that will come for your exam will be something like this. I will do this for you and you can try this yourself in a similar way. So let's see how we apply the geometric mean theorems. So first method, we can just name the coordinates. So A, B, C, let us say this is D. Now check the conditions. A, B, C, is it a right triangle? Yes, that is true. From the right angle, do you see the altitude? Yes. B, D is the altitude, its length is Z, which we don't know, we need to find. So let's first apply the part 1 of the theorem, geometric mean altitude theorem. When we are going to be applying that, it will give us the length of this altitude BD, which is Z. So what is the formula? It is the geometric mean of the two segments. So 8 and 25 are the two segments. Let's find the geometric mean. And because I'm doing the questions without calculator, I'm going to go for prime factorization to get the square root. So 8 can be written as 2 multiplied with 2 multiplied with 2. 25 can be written as 5 multiplied with 5. So let's take the pairs out. So 1 2 will come from here, 1 5 will come from here. So that is 10 square root of 2. So you got the length of the hypotenuse or your Z value. So I'm putting that in a box. Now you know your Z, you need to find X and Y. So X, I'm sure you are able to see, is the shorter leg and Y is the longer leg. So now we are going to move to the part 2 of the theorem so that we can apply the geometric mean leg theorem. So let me write the name. So geometric mean leg theorem. So when you are getting this question for a free response, open-ended, you have to show all these steps, you have to write the reason, which theorem are you using, what is the justification, what is the reason for using that. Okay, so look at this one, X. X is the shorter leg. So the formula says that X is going to be the geometric mean of the whole length of the hypotenuse, which is AC. So let's find that. AC is going to be 8 plus 25. So this is going to be 33 units, right? Now this 33 you have got, and what is the segment closer or adjacent to X? It is 8. So that means 8 will be multiplied with 33 to get the value of X. Now again, because we are doing everything without calculator, let's write the prime factorization. So 2 multiplied with 2 multiplied with 2, and 33 is 3 multiplied with 11. Okay, so I don't see much of pairs here, just 1 2 which can come out. So we are going to take this 2 outside. Inside you have 33 multiplied with 2, so which is 66. You can keep it like this if you don't have a calculator. And here for the value of Y, because it's the longer leg, so this time you're going to take 25 segment because it is closer to this Y. So this is the geometric mean of 33 multiplied with 25. Again, we can do the prime factorization. 3 multiplied with 11, so we are writing as product of primes. And I know this 25 is a perfect square, so I can take it out and leave the 33 inside. So we have got our X, we have got our Y, and we've also got our Z. So all three have been done. So such a question can come easily in your exams, very, very important. You should know how to apply the geometric mean theorem. So this was an application of geometric mean theorem. So both parts are very, very important. 100% in your exam you'll get a question from this. So to find the unknown measures, we are going to use the theorem. Let's see some more examples. Okay, so this is another question, same type. You have to find the three unknowns x, y, and z. As you see, it is not mentioned that you have to use geometric mean theorem, but looking at the figure again, you have to identify the z. So I'm going to be doing this quickly since we've seen so many questions now. So the first part of the geometric mean theorem, which is the altitude part, tells you that ML, which is your altitude here, x, is going to be the geometric mean of the two segments. So 20 and 5. So it's very easy, it's 100. So the square root will be a perfect square, 10 units. So you have got your x as 10 units. You can put it here. Next you need y and z. I hope you all can observe that y here is the shorter leg and z is the longer leg. So we are going to now use the geometric mean leg theorem. So what does it say? You need the length of the hypotenuse. So kg is the hypotenuse, which is 20 plus 5, so 25. Now the segment closer to y is 5, the segment closer to z is 20. So we are going to be using that. So y is the geometric mean of 25, the whole of the hypotenuse multiplied with the one which is closer, so 5. And z is going to be the length of the hypotenuse multiplied with the one which is closer, so 20. So how much is this? This is going to be 5 square root 5, because 25 is a perfect square, it will come out. And here again 25 is a perfect square, it will come out, and you're left with 5 times square root of 20. So 20 can be written as 2 multiplied with 2 multiplied with 5. And here you can take this 2 out. So 10 square root of 5. So now you can put in the values. This is 5 square root of 5 and this is 10 square root of 5. So if you observe, we have solved the entire question. We've got the all values of x, y, z without using a calculator. So the method that we have used here is prime factorization. So practice more questions of this type so that you become expert in solving geometric mean theorem questions. Last question for today, which is in the form of a word problem. So sometimes you may get a figure like this and a long word problem. Don't get confused, look at it carefully and you will understand which topic it is from and what you have to do to solve it. So let's read it. At least a word problem should be read 2 times and you have to highlight the important information always. So let's read it together. A path forms a diagonal of a rectangular path. So I hope you can see the rectangular path. This is the boundary or the path. A bench is placed along the path at a point that is closest to the fountain. So where is the fountain? Fountain is here, let's say capital F. Bench is here, so let's say point capital B. Okay. And this point is 30 yards from one end of the path and 50 yards from the other end. So this length is 30, this is 50. So maybe let's keep this A point, this point C. So I hope you can observe that this is a right angle triangle and your BF is the altitude. So here you can all see the right triangle. Maybe let me just highlight it with a different color. Okay, so this is point A, this is point F, fountain, this is F to C. Excuse me for not straight line, but I hope you're able to see. I'm drawing it with freehand. Next is from point A to point B and from point B to point C. Now I'm highlighting the altitude. So from the right angle, you are dropping the altitude to the hypotenuse. So this angle is also 90. So let's write now. AC is the hypotenuse. BF is the altitude. And you can see that angle AFC is 90 degrees. So all the conditions for the theorem of geometric mean is true. So definitely we can apply the theorem, geometric mean theorem. What is asked? What is the distance from the bench to the fountain to the nearest yard? That means BF is what you need to find, which is nothing but the height of altitude or the length of altitude. So we are going to be using only part 1 of the theorem, geometric mean altitude theorem, because it is not asking for AF or it is not asking for FC, it is just asking you for the length of altitude. So let's just do the first part, very easy. So your BF, which is the height of your altitude, is the geometric mean of the product of the two segments of the hypotenuse. So one segment is 30, one is 50, right? So just multiply them. Now you can use prime factorization. This is 3 multiplied with 10 multiplied with 5 multiplied with 10. Now I'm not going to break these 10s because these 10s are already in pairs, so they can easily come out. So 10 comes out and inside you have 15. So if you want to use leave your answer without a calculator, this is going to be the value. And if you want to use a calculator, you are allowed, then you can do the square root of 15 on the calculator and convert your answer in decimals also. Don't forget to round it off to the nearest yard. So that is all for this session. I hope you've understood what kind of questions to expect from geometric mean theorems and both part of the theorem and the word problem. All the best. So that's all for the session today. Wish you all the best for your upcoming exams. And before you end from the video, let me remind you to like, share and subscribe to my YouTube channel. Put down if you have any comments or questions. I'll be happy to answer them for you. Bye everyone.